Hello there, my name is Georgie, and I'm here with my glowing red microphone to talk to you about my new project, which I'm really excited about. Well, I created this project for the GitHub Copilot CLI challenge on the community, where I write articles usually. I have not really participated in any kind of coding challenge yet, but that's about to change because this challenge felt about right. Why was it? Because I use Copilot every single day for my personal projects, and it's awesome. I like using it. It has so many different models, it has so many features, and it's easy to use. At the same time, as a developer, I like using CLI tools, and I'm so happy that it's right here now. I decided to give it a try because I need to give it a try at some point, right? But desire for participation gets you nowhere if you don't have a good idea for the project, right? And if you want to be successful in the challenges like this, your project should be fun, creative, useful, and interesting. And this combination is quite a tough combination because there are so many ideas flying around and so many creative applications written already it's almost impossible to think about something new, exciting, interesting, and stuff like that. But it's not impossible. When I started thinking about the project idea, I started to play with the word association. So I started like, okay, this project is about Copilot. Copilot reminds me of pilot, and pilot really associates with airplanes, right? And if you're anything like me, you love, wait for it, airplanes. They are amazing piece of art and science. This plane is actually based on the real model. This is Boeing 737-800, and even the serial number on this plane matches the real one, which is super awesome. I love it. This is a beautiful plane, one of my favorites for sure. Okay, enough about this. Okay, where was I? So I decided to create something related to airplanes, aircraft, because I'm an enthusiast. I love watching up the sky whenever I hear an engine going like 800 kilometers per hour or something like that, because this is just exciting, right? And best part in being an aircraft enthusiast is that you can kind of play a guessing game when you see a plane in the sky, right? Like for instance, which make is it, which model is it, where it took off and where it's gonna land or something like that, or maybe which airline is it. It's sad because I'm not really good at this game. I'm not. However, there is one problem, one major problem, which is I'm a busy person. I'm a software engineer. I write code all the time, so I cannot stand outside all day long watching planes go above me and play this guessing game. So this is not the ideal situation, right? So I decided to create an application that does it for me, meaning it notifies me every single time a plane flies over my head, basically. So if I can see a plane, I need to be notified by this application. And I've had this idea for a long time now, and I was just waiting for a perfect excuse to write this application. And boy, do I have this excuse right now. And I did implement this application. Let's fire up and let's see what we have in action. Alright, so this is the moment of truth. The web application in action running right here in my browser. This blue dot here is my location. Well, virtually, because it's not my actual location. I do not want to expose my actual location for privacy purposes. And for demo purposes, I randomly picked San Francisco. I hard coded this location and I'm using it temporarily. And once I'm done with the demo, I'll switch it back to the normal mode. So when you open the application, it will ask you for your location so it can display planes around you. That's the only purpose. This application doesn't have any persistent storage, and user data such as IP addresses or coordinates is never stored, not even in the cache. They are used purely for real-time calculations, and that's it. The code is open source. You can check the code. This is everything is open, so make sure to check out the code. So the circle you see here, this circle, is what I call the detection radius. It's basically a 12-kilometer radius circle, which is about 7-8 miles. And whenever a plane enters this area, the application sends a notification with the aircraft's basic details. And those details are fetched from the OpenSky public API, which provides real-time information about publicly accessible aircraft around the world. Let's see this API, how it looks. So this is their website. This is quite a good service. I like using it. You can actually check their flight map, which is kind of similar to mine, but not really, because they have way more planes. But that actually makes sense because the goal of my application is to let you know what's flying above you without overwhelming you with a full global map view of planes. It just focuses only on what matters, your immediate airspace, and that's it. And it just wants to send you notifications about the planes above you. So that's pretty much it. You can check out their service. This is really awesome and quite an interesting one as well. Check this out, how many planes are there in the world. This is just amazing. That's why I love it. Okay, so now you might be wondering, I mentioned notifications, but you have not really seen any yet, right? And especially a few planes crossed this detection zone here, but still there were no notifications. That's because they need to be enabled in the first place in the settings. So let's head over there and turn them on. We have settings right here. When you open that, you can see that there is a separate section for notifications, which are turned off right now. So you can have the application notifications and also the browser notifications, but you can also have both of them together. So let's turn them on. What else we got in here? We have unit system. You can actually convert from one from another. You have like kilometers, meters, kilometers per hour. And also we have imperial system like miles, feet, and miles per hour. This is for Europeans like me, basically, who are more used to this kind of system. And this is for Americans, but actually I've lived in both continents, so I'm used to both. So this is not an issue for me. I can use both. And also, I'm pretty comfortable with the knots. I am an aircraft enthusiast, so I need to be familiar with knots. So this knot system is also pretty comfortable for me, so I feel pretty comfortable in any situation here. How awesome is that? Okay. You can also change the default theme here. You can have dark, and of course I have dark because my eyes just suffer from the bright light. You can also have light theme. You can also have the automatic theme, which is basically time-based and depends on whether it is night or day, wherever you are. It will show you the appropriate theme. That's pretty much it. So let's see how it works. So let's turn them on and let's convert it to Imperial, use knots, use light theme, and save. There we go. So we have a new notification just arrived. How awesome. Let's check it out. This is our new notification, and you can see actually every notification in the current system. Okay. Here it is. So yeah, the country is United States, altitude is 3,000 feet, and another notification just arrived. Okay, brilliant. Speed is 226.7 knots. We have heading value, we have distance, and we have this identifier here. So pretty awesome, right? I like it a lot. Let's turn off the notifications to make sure that it doesn't sound too loud here. And let's get it back to kilometers. And of course, get it back to the dark because I like the dark theme more. All right, so you maybe have noticed that we have different kinds of statistics here, like how many aircrafts have I spotted, also the closest plane right now, which is this plane right here, and it's just 500 meters from here. And it actually records the fastest speed that's been recorded up until now. You can also see that the planes are visible even outside of the circle, like these gray planes right here. That's basically to show you which planes are approaching your circle, and also to calculate how busy your area is. So this statistic right here shows you how busy the traffic is near you. But it also has a very interesting purpose, which will be discussed later when we talk about the backend caching strategies used for this application. So we checked out the notifications, and let's move to the logbook, which basically is a log for the planes that have flown above you, basically. You can export in JSON, you can export in CSV, or maybe you can clear them all. Yeah, you can do anything like that. Let's clear them to check out how it works. And now it's gone, right? You can actually clear the notifications as well, or maybe mark all of them as red, or maybe let's clear them all, and now the notifications are gone. All right, and actually you can also clear up these statistics right here from the settings window, and they are gone. Awesome, right? You can actually check out the information about me as an author. This is a fun Easter egg in the pilot uniform. That was my dream as a childhood, so I just put it in there. Okay, so yeah, you can see my links here like GitHub, LinkedIn, Twitter, and whatnot. You can see what's the project purpose here. You can actually check out the privacy disclaimer because that's very important, because this application is privacy first application and nothing is stored in memory. This application doesn't have any database or anything like that. It's completely, let's say, stateless. And the features that are planned, it's right here. You can actually check it out from the What's Next link. It's the same window. You can go back to the social links here to show you what links are there. And let's check out the contribution window, which is also very important because I've got the Discord, GitHub, YouTube, and dev.to article links provided here, which you can check out and just contribute to the community. I will welcome any one of you to the community because this is just getting started and we can do so much more together. This application has a lot of potential and I really hope that we can build something really, really valuable and beautiful. Let's move to the next part and explain the architecture of this application. Alright, now let's briefly talk about the architecture of this application, which is really the meat and potatoes of the whole system. This is where things get really interesting. Now, you're seeing a familiar view from our demo session, and if you look at the map, you will notice that the planes appear in different colors, right? Here is the red color, yellow, green, and a bunch of different gray airplanes here. So that really depends on their distance from us. And there is a legend in the left bottom corner that maps distances to the specific colors. I mentioned that planes showing outside the detection circle, I mean these planes here, for instance. So they serve kind of important purpose, and here is why. So this application provides periodic updates to users. Now imagine we have a lot of active users, a lot of active current users. The number of requests to the third-party API could quickly grow and hit the provider's rate limits, which is a very dark place to be in, because in that case, you just won't be able to serve any more requests. You need to call the third-party provider to fetch the data and then respond to your clients. Otherwise, how would you, right? So I needed to design a smart caching strategy, one that minimizes external API calls while still providing fresh and reliable data from my backend application. And that's where two important components needed to come into the play. One is the bounding box, which is basically a 50 by 50 kilometer square, something like this maybe, because the distance from here to the edge right here, here is 12 kilometers. So no, it's gonna be even bigger, I think. It's gonna be even bigger, definitely. Something like this, probably. All right. This is 50 by 50. And also the grid cell, which is a 22 by 22 kilometer square, which is gonna be something like this. 22 and 22. All right. So these two concepts play a crucial role in optimizing the system, and we will see why. I'll explain exactly how they work together. But first, let's quickly walk through the overall architecture, because that's also a very interesting point of the application. All right, so this is our application, and as you can see here at the top, we have our front-end application, the one we just saw in action, and at the bottom here we have the third-party data provider, which is basically the OpenSky public API service, right? Now, you might wondering why not call the third-party provider directly from the front end, just like this, right? Well, first, security reasons, because exposing API credentials on the client side would be extremely unsafe, and it really would be vulnerable to abuse. And the second, consistency and control with the backend service is much easier. We can standardize how data is fetched, processed, filtered, and delivered to the users. And that's way more predictable and consistent than just relying on the users that they won't do anything malicious, right? And third, very important, the credential management. The backend maintains a single controlled set of API credentials, and this is exactly what we want, because we don't want to use bunch of different API users, and we can definitely ask users to provide their own credentials. That would be kind of silly, right? So nobody does that. So yeah, I just decided to build this backend system here in order to avoid aforementioned problems. As you can see here, there is no persistent storage in this architecture, no databases at all, because this application simply does not care about any kind of data, any kind of user data, any kind of location data. It's not needed. It just needs a temporary cache, which is cleared after some time. So yeah, that's how it works basically. And speaking of cache, this is exactly where the real optimization magic happens. And let's see how. Alright, so let's talk about the caching strategy, which is the most important part of this application. You remember I mentioned grid cells, right? You are looking at one of them right now. So the grid cells are essentially geographic areas where multiple airplanes might be present at any given time. Instead of tracking every single user individually, I group users by location. I do this by rounding their coordinates to the nearest grid cell. Each grid cell represents roughly 0.2 latitude by 0.2 longitude, which translates to about 22 kilometer by 22 kilometer, or this is basically a 484 square kilometers. So this is how it works. So 1 degree represents to 111 kilometers, and 0.2 degrees is going to be roughly 22 kilometers. And that's why this is 22 kilometers. And when the application accepts the user's coordinates, these coordinates are immediately rounded to the nearest 0.2 degree. And that's how the grid center is calculated. The grid center in this case is this one. And for example, when a user connects their coordinates, this grid center is calculated straight away. And whenever another user joins and it has the same grid center, which basically means the same cache key, they fall right into this existing square, let's say. So what basically and what in reality happens is that the cache key is calculated by the grid center coordinates. So in this case it will be something like 48.8, which is basically this number, underscore 2.4, and make sure to wrap it with the quotation marks to show that this is a text. This is the key basically. And we have airplane data as a value for this key, some kind of JSON value where we have different kinds of airplane data, and this data is shared across this whole grid cell. And any other user within that geographic area will reuse the exact same cached data, which is pretty optimal. Now, once the plane data is retrieved and cached, each user only sees aircraft within their personal 12-kilometer detection radius, which we saw in the front end, the circle. And this is centered on their exact location. So this is not shared. This circle is really kind of individual, let's say. And this is to filter planes just for you in the front end. It's not filtered in the back end, rather it's done in front end. And basically the reason why it is done in the front end is that it minimizes the back end processing power and keeps the system more flexible and more scalable. So there is an important edge case here though. For example, if a user is positioned somewhere here, or maybe even on the edge of this grid cell, they might miss planes that are flying just outside that grid boundary, right? So, for example, if a user falls into this grid and there is a plane near to this user, this is some kind of plane, let's say, that's flying over this user, and it's near to it, it still cannot see it because this grid cell only covers what's inside this grid cell, not the outside. So this is quite an important edge case that should be considered. 50 kilometers here is the huge area. So basically what it does is, using the bounding box, we fetch a slightly larger area than the grid cell itself. I mean, it's not slightly, it's much bigger, obviously, but yeah, it's relatively bigger. So basically, instead of requesting data strictly for this 22 by 22 kilometer grid cell, the backend actually fetches this 50 to 50 kilometer grid cell, bounding box, sorry. And this is centered around the grid cell. By expanding the queried area here, we ensure that users receive a complete and all-around view even if they are positioned near the edge. For example, this user, C, is placed right onto the corner, but it will still receive the notification of this plane D, because plane D now falls into this bounding box area here, which means that it will be fetched into the front end, and this means that the notification will be received by the user C. Right? This is how bounding box actually solves this issue. But we need to distinguish bounding box and the grid cell because they serve completely different purposes. The grid cell is used for grouping users and managing cache entries, whereas the bounding box is used purely for safe and complete data retrieval. So yeah, those two are very important, and one does not replace another. They are two different components of the whole system. If a new user appears inside the bounding box but outside the current grid cell, for example here, they will not reuse that cache entry, this one, right? Instead, a new grid cell will be created for them, something like this maybe, and basically a new bounding box will be created on top of this. So it will be a completely new process and completely new set of components created for this user and every other user that falls into it, right? And that's how we maintain the robustness of this application. This architecture makes this application to work reliably and consistently. And finally, if you are a math nerd like me, you can check out the calculations here, which formulas I used, the constants, for example here, how we calculate longitude based on latitude. This is very interesting. We use cosine here to calculate 1 degree longitude. For instance, it will be this times cosine 60 degree, which is Oslo in this case, and it's going to be 55.5 kilometers. This is pretty simple and easy stuff. Also, we can convert kilometers to degrees, which is shown here, how it is calculated. And all of those calculations are done in the code as well, which you can check out. This is really interesting. And there's many other stuff that you might find interesting. So be sure to check out them. Also, there is a bounding box calculation. So basically we want to calculate all the coordinates of the bounding box to be able to fetch the data based on the provided bounding box, right? For instance, if this is our bounding box, we need to know the coordinates of this, and this, which are basically latitude, minimum, latitude, maximum, longitude, minimum, and longitude maximum. And they have their own formulas, how they are calculated, and that's really interesting. And here is the example of Paris, which is this coordinates, and how we calculate the bounding box coordinates here for Paris. And also how the grid rounding is happening. So basically this is exactly how the cache key is calculated, right? This is really important. This is actually one of the cornerstones of this application, how it is calculated. So this formula is really, really important. And here is the example of the same location here. For example, if this user is in Paris, this is how the cache key is calculated for them. So that's pretty much it. And that's my project for the GitHub Copilot CLI challenge. I hope you liked it. I certainly did, especially the creating part of this application, because it was quite complex and there were so many moving parts. It's so exciting to find out how you manage all of them and make everything in order. And it's so much fun, I'll tell you that. And one thing I need to mention is this repository is completely open source, so you can contribute to it. You can clone the repository, you can fork it, you can make pull requests, register issues, and you can also reach out to me with questions using the Pilotronica Discord channel or the article comments as well. So I will link both of them in the comment section or maybe in the description, so make sure to check them out. Thanks for watching, and I'll see you in the next challenge.